So for now, when you've got the part with the super classes and the hierarchy, you have them, first you've got the person, which is the most abstract class. And then based on the person can have the role of employee as well as you have him as a manager. And the manager is more specialized. So based on this hierarchy, you will have to define the person. Let's have them in this way. For this person, as you can see, over here you've got it with public. So public is when you've got the plus. So plus, in fact, here means public. Okay. So this is public. And then you need to say which is the type. So the type over here after public, you need to say that it is string. So you need to read it with, first you've got plus, then you need to look at the end, which is the type, and then which is the name of your attribute. So in fact, here you've got a public string name, then you will have the birthday, which is also public, okay, because it has the plus. Then you have the CNP. CNP has a minus, so it's private. Okay, so this one is private. Oh. Yeah, okay. And in this way, you also need to have a reference here based on address. So when you've got an arrow like this one, it means that I have here an address, okay, A. So the address exists here, an address A as referencing an object of this type. Then the person will have the constructor based on its parameters, which are the 4 of them. So it will be name, then after name I've got birthday, I've got CNP and address, and you need to set all of them as using this dot name equals name, as well as this is birthday to be equal to birthday, and your personal numerical number to be equal to the one which is provided in the function, as well as you've got the address. So for the address, you also set it in the same way. You also need to set a default constructor, whether you do not want to set them by default. I mean, everything all in one. You have this empty constructor. Also, what you can do is to move, meaning that you need to change the address. So in fact, with this move, it is like a set. Okay, you don't return anything. So this is why it is of type void. And you will have move according to the address that you provide here as an input parameter, such that my address will be equal to the new address that is provided. Then for my employee, you see that you've got this arrow. This arrow means that for it, you have the word extends. So employee will have this extends. Okay, extends of person. And this person, you see here that you have it, you have a salary for them, meaning that you will have the public employee for salary. The super is called implicitly in this way, so calling the person constructor, and you set the salary. What you can do here is to also set the name, birthday, and salary for another type of constructor, such that this you will have the this of salary to set it, and you also set the name and birthday. You can also have several arguments like before to call the constructor of person, the constructor of person based on name, birthday, CNP, and address, meaning that you have the super of name, birthday, CNP, address, and you also set the salary. Then if you want to increase the salary, you need to provide an int add of certain value such that the salary will have a plus equal according to the value add. Then you've got the manager. The manager is also an employee. So it will have to extend employee. It is in the same way. And keep in mind that you've got this kind of arrow, which means that. And here keep in mind that this arrow means that you have an object of type address inside the class person. Then you've got the C salary, which means that you will have to display the salary as well as you can call the one which is inherited. So you can see the salary of the employee that you extend. Okay. Then you also have your substitution principle. So it means that if you have S as being a subtype of T, then all the objects that you've got of type P, they can also be replaced by exactly those objects that you've got of type S, so the substituted ones. So for example, over here, I've got a person P. And for this person P, I say that it is equal to a new employee. Then for my person P, I can do the move and I can simply take them to a new address, as well as employee E. You can set it as being a new manager. And for this manager, you can do an increase. While for the manager M of new employee, you will receive an error. So you need to find out what is replaced by another, okay, whether you want to see the salary. So for it, you have the superclass object. So always you've got object based on which you've got the constructor. You have the toString to find out more about it. You have the clone, you have the equals, whether two objects are the same, the hash code for finding it inside the memory. Also, you have the threads for it, whether it was finalized. Also, you have the get class to know the name of the class. You also have the notify all for the threads that exist in your program. You've also got the wait, whether a thread needs to find and to get the response of another process. So you can wait until it is notified, or you can wait for an amount of milliseconds. Then you also have the equals. So equals is when another object is exactly the same. So whether this is in fact the other of object, then we return true. Whether the other object here provided as an argument is null, then you return false. Whether the classes of two objects are different, then you return false. If not, you can create an instance of that class, of that object, and you can transform it as being an employee. And for it, you can know whether or not the salary is the same. So if the name equals the other name, whether the salary is equal to other than name, as well as whether the hire date is the same. Also, there exists the static polymorphism. So based on operator, you've got overloading. So you can have 1 plus 2. This is when you have two integers. Then you can have a floating point, meaning that you have to float values. You simply associate them. And you've got also a floating point addition. When you've got 1 plus 3.7, also the result is of type double, as well as what you can do is to concatenate two strings, like hello, you can concatenate with word. When you've got a method overloading, it means that for the method you have the same name, but you have different arguments. So you can have a public int add of an int x, as well as you can have it of type double, and you can add the x. And this type, which is chosen for the x, is just known as compile time according to the type of the argument which is provided. Then for the dynamic polymorphism, you have a method dispatching. So here there is a method overriding. This is when you redefine it in subclasses. And for this one, you have the method which is simply decided at runtime according to the object. So it is like here I've got a person. I have a new person. I have the p.toString, as well as it can be an employee, and I have the e.toString. So it will simply look at the current object, which is of type E, and it will simply call the toString for it, such that based on my person, I will also have the salary of this participant. I will add here the schema. Then when you have an override, this is when you have a method which whenever you get the error, it means that it doesn't override it well, as well as whenever you have the overridden methods, they will not be inheriting. So if you have final methods, you can also have final classes as well as private methods. Now, let's see. When you have the overriding, you have to have the same signature of the method, so the same name. Then you have the return type, okay, which should be kept. And you have the accessibility, which you shouldn't narrow, okay, but you should make it as wide as possible so it will be public. Also, you can have a method that can throw you an exception or no exception, so it depends what you include there as a behavior. So let's see. When you have overriding and overloading for the method name remains the same no matter whether it's overriding and overloading. Then when you have the argument list for overriding, it means that it remains the same, while for overloading, you will simply add or you can subtract. So this is a variable length. The argument list will vary. The return type now, when doing the overriding, it can be of the same type or you can have another covariant type, while for overloading, it will be totally different. You can also have the throw clause. So keep in mind that for overriding, you shouldn't you shouldn't throw other exceptions, other check exceptions. You should just narrow them. While for overloading, okay, this one you can defer and you can throw your errors. For accessibility, you should have it less restrictive for overriding, though it will be public, while for overriding, you can simply change it, whether it's public, private. Then for declaring it, you will have a method that can be overridden just in a class. While a method, you can overload it no matter what, whether you are inside the same class or whether you are in a subclass. Then for the method call resolution, this is like at runtime exactly according to the type of the reference, which is the method that I simply want to have it executed. While for overloading, this is all that happens at compile time. And according to it, you will have a type of the reference, and this one is simply selected. So you have a method name, and the arguments will vary. So at simply at compile time, it will know which one is it. But with this one, with overriding, this is according to the runtime argument, because you can have several types, and according to the type, you have another method which is run. Then you can have a static method hiding, meaning that method hiding is when you've got the same signature, so the same method name. Also, you have the hidden methods, which are not inherited, of course. And for it, you also have the compile time. So all of this in method hiding, it happens at compile time because you need to use the reference type. Such that whether you have a class 1 and for it you have a static method sm and you print the argument c1 and you've got another method m inside c1. You can also have both of them inside the class C2, where C2 extends the class C1, and I've got the same two methods, SM and M, but the output will be different as knowing which class is called. Then, for it, you see that you have C1 and C2 for it, like A, B, C, D. And for each one of them, you will call your argument. Okay, so which one, it will simply be displayed in this way. So let's see, what do you think that it will be displayed over here? Yeah. Let's see. Right, so we have this class as well as the rest. This is because of the formatting. So now let's see, based on the calls. Now you should think about each and every of the 6 calls. One should be retrieved by each one of them. Okay. We've got these classes. B size. In fact, class. Yeah, this is with C2, CD. So let's see what would be displayed for each one. So you can write in the chat now what you think that would be the answer. Maybe someone wants to respond in real time. So this is the case, as you can see with D, you cannot call it, okay, because you have it as, so you have the C2, it extends, but you also have the static SM for it. So it will simply be an object C1, okay. And you can have just, as you can see over here, you have a C1 of C1, you can have a C2 of C2, while you can have C1, C1 is the most abstract one, and you can put it as being a more specific one, as being a C2, but a more specific one like C2, you cannot make it equal to the most abstract one, okay, which is this C1. This is why this one will provide you an error. Let's see what it will show. Let's have it in this way. My one print and say this is 1, 2, 3, just to see them. I just display the one I need to print ln paper line. Okay, such that you've got A. A is of type C1, so when you call the method M, it will simply remain inside C1. Okay, so here A is of type C1. So this is why it simply stops here at this level. Then what you do have for the second part, you have A.sm. So A is again inside C1. You've got sm, a static method. So again, you remain at that point because A is of type C1. Then you've got B. B is of type C2. Okay. And now for this C2, you see that I want to call the M method. Okay, the M method is in fact, you've got the static one. Okay, so the static one, when you call it, it will simply go as deep as it can. So it will provide CN. Okay, so I will share here 1. It is C1. This is C1. This is C2. Okay, because you go inside B and you remain there. All right, but then you've got, again, you have the SM method. Okay, and this will also be with C2, while B is of type C2. Now, for C, it will be a C1, which will have the type C2. So which will be the result when you want to call the method M and SM. Which one goes deeper, in your opinion? So as you can see, you have the call with this one. Let's put it here. Even. Okay, and to see that this is what it shows. So firstly, you've got the C. C is C1, okay, it's being of type of C2. And you have the M method, okay, where the M method is this one, exactly with the void. So it is not the static one. So it will go as deep as it can. So this is why it has C2. Then you have the SM, the static method. So the static method will remain at the top level, okay? So it remains at the most abstract method, okay? It returns the call of the top definition. So you go in the hierarchy of classes, you see that C is in fact a C1 object, which you define as being a C2. So this is like with the person and employee, you have person P equals employee M. And when you have a static method inside person, This is the one which will be called. It won't reach the static one inside employee when you define it like here. Okay, so this is like when I have my person P equals new employee. Okay, and in this way it returns just at the top definition. So it will look, so you have it in this way. Top definition, C1. Okay, so it will look at the top definition of C1 because after C1, okay, underneath you've got C2. So it is like of writing here that this is my C1 and this is my C2, my specialized class. And when calling it with static, you just remain at this top level. While in C1, so it's when you have C1 of C1, it remains at this level. Okay, you don't go forward. When you have C2, what it does, C2 of C2, again, it remains at this level. Okay, so here, this is why the static method, this one, C2 of C2, so C2 of C2 for the method SM, so B is of type C2 because you have it in this way. And the way you define your hierarchy, your entrance point, so C2 is the entrance point in the hierarchy. Okay, while in this way, when you have it like here, C1 is the entrance point in the hierarchy. But for the static method, you remain here at the top level. So this is why with CM, you finish in C1. While for a non-static method, M, it will go underneath. So you have C2. You have it in this way. No, this is the one. Okay. All right. Such that you go, okay, M is not static, such that the method associated to type C2 is called. Okay. And here it returns the call of the top definition C1 because the method SM is static. Okay, this is how you define it. So is everything clear for you for this part? So whenever you've got static and you've got an object like this C of type C1, and then you initialize it as being of C2, like a person P equals new employee, and you call it based on the static method, it remains at the top definition. While when it doesn't have the static in front, then it will simply go down until its level, so being of this level C2. Okay. So a static method will be called based on the top context, okay, namely person. While for a non-static method, you call the class, the method, in fact. Okay, inside C2, okay, which is namely employee. So you have them in a different way. Let's see. So here with the polymorphism, you can have a shape. So a shape is the most abstract class, such that for it you will have the draw and erase methods, and this is how you define them. Then for it, you can have a circle, a square, or a triangle. Then for your circle, you will have to have a subtype of shape, meaning that you extend the shape, and you will want to simply write the behavior for these methods. So it means that you need to implement draw and erase, and the same is done for square as well as the triangle. So you have extend, and then you define the methods. Then you can have a random shape. So you can have a public static shape of random shape, and you can switch it to be a random either 0, 1, or 2. So whether it's default is nothing. And then whether it's 0, it means that you need to call the first type of figure. So it will be 0. Then you can have case 1 with square, or you can have case 2 with triangle. Such that based on the void main, you can have 9 shapes, and based on the 9 shapes, you will have a random shape, after which you will have to draw it. So you have them defined in this way, and they are simply randomly called, so you won't have exactly this order. Okay, so for each one of these 9 shapes, you will call the draw method. So it means that for the polymorphism, you will have the method definition. You've also got the attributes here above. Then for these classes, you will have extend, and you use some of its behavior. Then you have the class which is at this level. It will use the definition from this level. As well as you have, for example, the object. So it will be simply using this definition of the class. Also, you can have them like here. You can have again the method definition, where you can redefine the method and add some new arguments. So this is like here you have inside the class the definition of draw and erase, while in the ones here in circle and square you simply have to write its behavior for the methods like draw and erase. So it's exactly what you've got here in the green rectangle. For the abstract classes, you cannot instantiate them, meaning that you cannot have new, so you cannot have an abstract class equal to a new abstract class. They are simply defined as an implementation, as well as you have the subclasses, which will have details and they will have to implement methods. Also, you have a class which is abstract when at least one method doesn't have any implementation. It is like here, I have it in this way, draw, and I don't have anything inside it. Also, whenever you've got an abstract method, you need to write the abstract keyword in front, and you will also have the keyword abstract in front of the class. So for example, you have a 3D shape, meaning that you will write it as being a public abstract class, a 3D shape. And for the 3D shape, you will have a method, abstract method draw for it according to a graphics, as well as you will resize this drawing according to a certain scale. And you do not define it such that afterwards you will have to write its behavior. So you can have a 3D shape as being a new sphere, as well as you can have several shapes. And then you define that shape 0 will be a new cube, and so on. So for example, you have this client having an account, and this account can be a debit card or a credit card, and you've got this person, okay, as having a city street number. So let's see, always you start coding from the most isolated class, okay, which means that over here I need to define my address. So for the address, I will have a private string city. Okay, then street is also a string. I have a private int number. Then I have a constructor, public address based on the same name. I have a string city, int number, a string street, such that this dot city will be initialized with city, this dot number will be n, and this dot street will be s. Then what I can do is to have the getters. So getters means that you can have a public string. You need to return a type like get city. When I've got a get city, I don't need any argument. I just return my city. And because my city is of type string, this is why I have the public string with get city. I have the public string get street. Okay, it means that I return my street. Then I have my public int get number, and I return my number. Then what I can do is to have the setters, meaning that I initialize it with a value. Okay, so you provide a value, meaning that I have a public void. So you just set a value. This is why you have a void. And you have set city based on string new city. And this means that this city is equal to new city. Then I have a public void set number as being int new number. So always you have the attributes with camel case. You start in lowercase. And this dot number is equal to new number, as well as you've got a public void set street, which is a string new street. Okay, and I've got this dot street as being my new street. So this is how you define exactly this part. I will add it here. Then what you do have is, as you can see, you've got a client. I will go here, I have a new Java class, client. And for my client, I have a private string name. It is with minus, so it's private. Then I have a private local date, okay, of b-day. I also have a private string CMP. So for this one, I need to add a constructor. This is called constructor. And inside the constructor, I have a string name. I have a local date, okay, my birthday, and the string CMP. So it means that this dot name equals n, this dot l local date, okay, which is my birthday as being b, and this dot CMP as being lowercase CMP. Okay. For it, you will have a public void add account of account A. So it means that when you have such a method based on this definition, you will have several accounts inside it. So what you can do, you can have a private list account. Okay, and I will also have this account placed over here. Okay, as being accounts equals new, and let's have an array list. So this is how you can store elements without caring anymore about which is the maximum capacity. Okay, so you have this array list. Then it means that inside this dot accounts, what I need to do is to add a new account A. And this is how you place it inside. Then what you can do is to also have the boolean remove account of string IBAN, and it means that For it, you have a for. I have an account A inside accounts. And for it, I will have if A dot get, I have the IBAN for it. Let's see, account has a private string IBAN, has a private int amount with lowercase. Okay. Then for it, I have a public account of string IBAN and int amount, such that this dot IBAN is IBAN and this dot amount is A. Here I want to get the amount, so it will be public string. I want to search based on the IBAN, so I have get IBAN. I don't need any argument, I just return this dot IBAN. So when going inside here, if A dot get IBAN dot, I have equals ignore case because a bank account has the bank number and also the country like RO and so on, BCR. Okay, and in this way, I will simply have to find this IBAN as the parameter. So if it is this parameter, I will simply have here a boolean found as being false, boolean found here. Okay, I will have found as being true. Okay, and then you will have to remove it exactly at the end. So you have count, okay, to be deleted, delete account, which is none. Right. So it means that what you can do here is to also, whether it is true, you have the account that you want to delete as being A, and what you can do is based on accounts, you can have the remove, okay, based on the account A. And in the end here, you need to return found. So whether it wasn't found, the default value will be displayed, which is false, as well as if it was found, you have the return of true. Okay, so I will place this one also here. Then you have the account. Now this account has two ways of doing it. So it means that you will have a public boolean and you have them in both ways. This one will be an abstract class. I'll make it abstract. You have two types of account, debit card and credit card. And here you will have this boolean. Okay. It is a public asset boolean withdraw based on an int amount. You don't provide exactly which is the behavior because the other classes need to define it. And you also have the public abstract void deposit based on an int amount. Okay, according to it, let's see, you have the debit card, debit account. So for this one, you will have the public debit account as being what? As being the super for it. Okay, so you need to define it. While you also have the methods. And in this way, you have the extent of account. Okay. And you need to implement the methods. So in this one with the super, okay, you see that you have the insert of super for it. while you should also provide which are the values. Okay. So it means that here I need to have a string IBAN and an int amount A. Okay, of IBAN and A. Then, when can you withdraw money from a debit card? And this is based on Boolean. What do you need to check first?
If you have money.
Exactly. So you need first to be able to return the amount. So this is why you have the get amount and you return this dot amount. So here I need to check if this dot get amount is half. Greater or equal, no? Then the amount that I want to take out. Then what I should do is to also update the sum of my account. So you will also have a public void set amount. And this is a new amount, meaning that I have this dot amount equal to new amount. So here I need to update this dot set amount as being what? This dot get amount, out of which I need to subtract the amount which I want to extract. Okay, and in this way I will return false. I will return true that I did do the withdraw. Okay, so everything is done fine. If not, then I return false. So I can write else, or anyway it will reach this step. Okay. For deposit, what do you need to write? This dot. Deposit means that you do what? You set the amount as being this dot get amount plus my amount. Okay, so this is how you implement this one, as well as for account. This is the one. And now shortly to show you for the credit card. Okay, credit account. This one also extends account and it will want you to rewrite, okay, to override the methods. And now what I also do have is have the constructor. And you know that it's with super with IBAN, but what I also need is to have the max credit. So it means that this dot, okay, I also have it here as being a private int max credit. And this means that I also need to set this dot max credit as being my input parameter. Okay. And when I want to withdraw, what do I have to check? It is similar to this one. If so, it is a credit card, you shouldn't exceed a maximum limit. So you can have money placed in your account. Okay. So if it is less or equal, you will simply have to have a plus. So you owe the bank some money. Okay. And if not, it will not be available. Okay, so you owe the bank some money. You take a credit and you can buy several items, and then you have to you owe the bank much more money. When you want to deposit will mean what for a credit? You provide money, and when you provide money, it means that the amount that you owe the bank will simply be subtracted. Okay. And this is what you need to do for implementing this system. Okay, so I will stop the recording here.